Today, building with AI is less about the model and more about the system around it. That system is called a harness. Harness engineering treats the model not as the whole system, but as a single component inside a larger engineered pipeline. The harness validates the input, assembles the context, routes between models, checks the output, and triggers real actions. It makes the architectural decisions the model shouldn't. Which model to use, whether to retry, and whether an answer is even allowed. How did we get here? Let's trace it through 3 eras. It started with prompt engineering, the craft of writing precise instructions to steer a model. Phrasing, examples, and structure changed the output dramatically, without ever touching the model's weights. The toolkit was words, zero-shot and few-shot examples, chain-of-thought reasoning, a role, and a required output format. A better prompt meant a better answer. But a prompt is stateless. No memory, no tools, no loops. It works for simple tasks, but the moment the work grows beyond a single message, the prompt alone breaks down. As context windows grew and retrieval matured, we realized that what you put in the context matters as much as the prompt. This is context engineering, assembling, ranking, and compressing the right information for each model call. Pull relevant chunks in with retrieval, manage conversation history, summarize memory, re-rank for relevance. If prompt engineering is about instruction quality, context engineering is about evidence quality. But it's still just one model call, and complex workflows need something more architectural. And complex work isn't one shot, it's a loop. The harness is everything except the model itself. The tools it can call, the memory it keeps, and the loop that lets it act, observe the result, and try again. Frameworks like LangGraph, CrewAI, and AutoGen wire this together, with structured output validation and guardrails on top. Here's the surprising part. Constraining the model with rules, feedback, and checks makes it more capable, not less. As the saying goes, agents aren't hard, the harness is hard. So what does a harness actually look like? It's a pipeline of stages. First, the input layer. Raw input is validated, sanitized, and classified. Bad input never reaches the model. Second, context assembly. The harness retrieves documents, injects the system prompt, and adds memory, ranked and compressed to fit. Third, the model calls. It may use several: a cheap model to classify, a powerful one to generate, a specialist to review. Fourth, routing and control. Every output is checked against policies and schemas, then retried, escalated, or passed on. Reliability is enforced here. Finally, output and action. Validated results trigger real effects or loop back in as new input. Why go to all this trouble? 4 reasons. Reliability. Retries, fallbacks, and validation stop AI systems from silently failing in production. Control. Guardrails and schemas enforce good behavior, so compliance becomes a property of the system, not the model. Orchestration. Route each task to the cheapest capable model instead of sending everything to the most expensive one. And agentic flows. Outputs loop back as new inputs, powering agents that plan, act, observe, and reflect. Step back and the shift is clear. Prompt engineering's unit of work was a single prompt. Context engineering's was the context window. Harness engineering's is the entire pipeline. You moved from trusting the model to improving its input, to enforcing correctness through system design. And each layer doesn't replace the last, it wraps it. The prompt lives inside the context. The context lives inside the harness. That's what turns a clever model into a reliable system that actually ships.